Welcome back to this tutorial on using the Wikitude plugin for Unity to create a markerless augmented reality game. So in the second half, we're now going to add all of the game elements. In part one, we created the basic scene setup. So we've got all of the tracking stuff going. Now we can build our game. When you get to this point, you can build pretty much any game you like. So you just use Unity the way you usually do. The grid that appears in the tracking is basically your ground plane where you're going to put stuff. Okay, so all the tracking is doing is keeping your game scene aligned to the key points in your video feed. That's all it's doing. So from now on, you really just build the game exactly the same way as we did before. Okay, so let's begin. First of all, what we're going to do is just program this button here to go green when tracking's on and red when it's off, and also to set the actual height. So I talked about that height value of where the grid's going to appear in the previous tutorial. And if we just go back to the top of our controller code, just to remind you, we've got this height above ground set to 1. Now you could make this a variable so that you could create a slider, and one of the examples that comes with Wikitude actually does have a slider where you can change the ground height. That will change how high up that grid appears in your view through your mobile device. So feel free to play around with that, but we'll just leave it set to 1. Okay, so we're going to actually set this value in the on state changed. When this callback gets called, it's when that tracking button has been pressed and when these states up here. So when these states are set for the tracker, the callback comes down to state changed here. So it's in here that we'll actually add our code for changing the color of the button and also setting the height. So in here I've got this height value here. I guess we don't really need to put that there. You could put that like somewhere else on enter field of vision, or even right up in the start tracker function, because you don't need to set it every time. But if you do want to change it, then you would need to have it in here so that it's constantly updated. Okay, so this function, when it runs, it gets this new state variable passed through it, and we're going to test what that is. If it's tracking, then we change the color of that button to green. And then we also set our little internal variable that we created before is tracking to true, and we'll be using that when we start adding game elements. And then next we're going to test if it's initializing, set the button back to red, and of course set is tracking to false. Let's just save that and switch back to Unity and run. Now this isn't going to work in the editor, as I've said before, but the button itself, you'll be able to see it changing. Okay, so you can see that's working, and if we pull up the console, you can see that it's pushing out that debug log line that I've got in there, so you can see what's going on. The next thing you need is an actual zombie. If you want to create a zombie game, you need a zombie. So I've got this model that I've already created, or actually I got it from Mixamo. I shouldn't say I made it because I didn't. But I put it together in Mixamo and put on the animation. So this is a zombie character. Now on that zombie character there is an animator controller, and that animator controller has two animation states. It has walking towards you, and then it also has dying. If I just press play, we should be able to see that in operation here. Okay, so what it's programmed to do is to walk towards the camera. It's also programmed that when it gets hit with a bullet that we'll create just in a moment, it's going to run its death animation. Okay, so that's the zombie model. Now, I'm not going to go through all the intricacies of animating these characters, but you can have a look at my other videos to see how that's done. But very quickly, just in the animator for this character, I've got the walking, and then I have a trigger set to run the dying animation. And this trigger is called hit. Now that's quite important because that will be in the code to cause this transition from walking to dying. The zombie itself has a script on it. It's also got a capsule collider, by the way, which is a trigger. It needs that to detect when it's been hit by the bullet. It's got a script called chase, which is just here, and that's attached to the character, and the character has a rotation speed, and then it also has this variable picking up its animator so that it can actually change the transition or trigger that hit. Now the two parts to this really simple script, first of all there's the update. What the update function doing is working out the vector direction from the camera to the zombie itself, and this camera.main is picking up your Wikitude camera. If you have a look at the Wikitude camera here, you'll see that it's tagged with main camera, and that's very important for the code to be able to pick up camera.main. Let's go back to chase. Now, once it's figured out the vector direction that's between the zombie and the camera, it then sets the Y value for that direction to 0. That means that we can create a character that turns on the spot around the up axis. And it stops the character from sort of leaning over. So if your camera was down low compared to where the zombie's position is, it would actually tilt the zombie over and it would be coming towards the camera. And you don't want that, otherwise it looks a little bit strange. We then set the rotation of the zombie using a slurp function, which is going to slowly, every update, turn the zombie bit by bit to face the camera. And we use the rotation speed in this calculation to determine how fast it will actually turn around. So if you want the zombie to turn really quickly, then you would increase this value up here of rotation speed. The slower the speed, the longer the zombie will take to turn around, which means it will actually walk in a bigger arc if it's not already facing you. And then, you know what, this line here, I'm not even using this. This must be left over from something I've done before. I'll just delete that altogether. So this is your chase.cs script that you would attach to your zombie or whatever your character is. Now, if you want to do this and you don't have your zombie character, then you could use like a cube just to see how it's going to work. And if you do use a cube, it's not going to have animations on it, so you need to delete any reference to the animations, which would be that line, and then that line. And then this would still work with a cube with a collider on it. Okay, so let's now look at this on trigger, which is just triggering our death animation for the zombie, and it's also deleting the bullet. Okay, so on trigger enter, when our bullet or something enters into that capsule collider that we've got on our character, if the tag for that object is bullet, which it will be when we create it, then we're going to set the trigger for hit, and that will make that transition from walking to the death animation occur on our character. And then at the same time, we're going to just delete that bullet object through here. So just destroy it to get rid of it. So that's that chase animation. So I'm just going to save that, and let's go back to our other code. The zombie prefab gets passed through to the controller. So let's put up a public game object at the top here for zombie prefab, and we'll just save that. Switch back to Unity and click on your controller, and you'll find now that you've got this zombie prefab ready to accept it. So grab hold of whatever prefab, whether you're using a cube or a character, and dump that in there. Now the zombie that's in the scene you don't want there, so we'll just delete that altogether. We'll program this so that when you tap on the screen, you'll get a zombie appear on the ground location, and it will start to walk towards you, and then a double tap will push a bullet out from the camera's location in a forward direction into the scene. This will have to happen in an update function, and this is the exact same way that you would do it even if you didn't have the tracker or any video feed going on. So let me just paste this update function into our controller and go through it. So the first line is checking if it's tracking. If we're not tracking, there's no point in putting things into the scene and shooting bullets. So we're just going to return straight away. And this is the reason why we've got this is tracking value set further down in that on state change function there. Okay, so let's go through the rest of this. First of all, we're going to test if there's a double tap. So if you've tapped 2 times on the screen, you're going to instantiate a bullet. In this case, the bullet is just a basic sphere, which we can create with this line. And we're using the GameObject.create primitive type sphere. So we'll just get the stock standard sphere in our scene. That sphere's position we're going to set to the position of the camera. So it's going to come from the camera and straight out. We then add a rigid body to the sphere because it doesn't automatically come with a rigid body. We're then going to grab that rigid body with getComponent and add a force, which is the forward direction of the camera. And we'll give it a bit of oomph by multiplying that by 100. If you want your bullets to come out faster, then you would change this multiplier here. So we're taking the camera. If we just go back to the scene, I'll find my camera. Okay, so here's our camera. Just move this around a little bit. The scene's all happening in here. The video itself would be on the back plane there, and all of the zombies and the bullets are going on inside here. Now for the camera, the spheres instantiate at the position of the camera, and then they're pushed out along the forward vector, which is this blue vector. So the bullets are going to come out here and be pushed out that way into the scene, which means that the center of your mobile scene here is basically where you could imagine some crosshairs should be. So when you shoot, it will always go from the middle out. If you want to shoot a character over here, it's a matter of turning your device over to that way until that character is in the center of your screen and then shooting at that. Okay, so that's the shooting of the bullet. And then we, of course, tag the sphere with the tag of bullet. Now, this actually reminds me of one other thing that you need to do. Just go back to Unity and let's click on our zombie prefab. You'll need to create 2 tags for this particular game. One will be zombie and one will be bullet. So the zombie tag goes on the zombie character, as you can see here, and then you'll need to also create this bullet in the add tag section in order to add it with the code. So if you try and add a tag with code like this and that bullet tag does not exist in that list, you'll get an error. So make sure that you've done that. All right, so that's the bullet. Now the next part of this is testing that there's been one touch, or I should say, yeah, one touch, and then the phase for that touch is began. Okay, so we've tapped the screen basically. We're going to shoot a ray from the camera out into the scene from the mouse position, which is also our touch position. So that ray is a vector going out into the scene. Now we're creating a ground plane just in code. This won't actually exist. Okay, so it's just a construct that's mathematically determining where the ground should be, and then we're casting that ray of the touch position towards the ground and finding where it hit. Okay, so just back in here, click on my camera again. Imagine that you've got this ground. Well, let's say that this grid here is the ground, Unity's grid. So you tap on the screen and the ray will come out of the screen and go down until it hits the plane of the ground, and then that point, or the distance of the ray to that point, is then used to calculate where the zombie should appear. So that's what all of this is doing. and this line here. So this is actually getting the position where that ray is intersecting the ground plane. And then we're instantiating a zombie at that position and setting it to a 0, 0, 0 rotation with the quaternion dot identity. You could give it like a random rotation here if you want them to appear and be facing in any direction, which could be interesting because then they will use their slurp function to turn around slowly towards the camera. Right, so that's the update function in the controller that's going to instantiate and create our zombies for us. Now the last bit of code is going to be down in the set scene, so that when the tracking is lost from the video, we want to make any of the objects in the scene, which are the zombies and the bullets, to not render, as well as the grid. So the grid will turn itself on and off based on whether tracking is picked up or not. So in here, let's just add another little bit of code, which is going to turn off the renderers and turn on the renderers based on what the value of A is. So for the zombies themselves, we're going to go through and get all of the game objects with tag zombie. This is why we tagged our objects earlier. And with each of those zombies, we're going to loop through and find all of the renderers that are on that. So the zombie character itself doesn't have a renderer on the top level. It's actually made up of a whole lot of other little bits and pieces. And if you have a character that is constructed in this way, then you do need to loop through all its renderers to turn them off. You can't just turn off the high level renderer because there isn't one. With the bullets, you can do it. So in the case of the bullets, we're getting all of the bullets and then we're looping through them and just turning off the actual render for those. So these are the two different ways that you actually turn off renderers based on how your character is constructed. All right, so let's just save that. Now, one final thing that I do want to do before we continue is to actually destroy the bullets and destroy the zombies. So up here, where we've created the bullet, I'm going to put in a destroy, and we'll destroy this sphere, let's see, after, let's say 5 seconds, because I guess I don't want these objects cluttering it up, and instead of going ahead and building a complete cleanup system, this is probably just the easiest for now, so we'll save that. Now we'll go back also into the chase code for the zombie, and after the zombie's death animation has occurred, we will destroy the zombie, so it will be this .game object, and let's destroy that 5 seconds as well after the zombie has died. So it's going to play the death animation, lie there for a little bit, and then it will just disappear out of our scene. Now before we build this out to see how it's operating, I just want to add in one more thing, which is a ground plane that has shadows on it. That is a ground plane that has shadows in it, because nothing embeds a virtual character more in an actual scene other than having it aligned properly. So in the hierarchy, is for it to have and we shadows 3D that actually fake it being there and it exists. That's going to add in our ground plane. Now you can make that much bigger if your game is going to cover a lot of area. So everywhere that you want shadows, I'm just going to increase the scale here to 10. I'm also going to make sure it's positioned at 0, 0, 0. The mesh collider can stay there because we want the bullets when they come out of the screen to actually bounce and roll along the ground. And we've got our mesh renderer, which obviously we do need to see it, but we're not going to use this standard material. So we're going to use a transparent shadow receiver material, which will come with the Wikitude plugin. So let's just go and see if we can find that in materials. Here it is here. So this one here, transparent, drag and drop that onto our plane. So it's called the transparent shadow receiver, and it's a custom transparent shadow receiver shader on there, and that'll allow us to see the video through that, but we will get a nice shadow appearing on the surface. Now, one more thing I should explain before we build this out and have a look is the position of our shadow plane and the position of where our zombies are being created. Now, that grid is not the grid where the zombies are being created. Okay, so that grid itself, or it could be, it depends where you've positioned the height of the grid. But the most important thing is we find our script. And if I just move this over here. Grab the plane and show the script at the same time. In our code that's creating the zombies, the ground plane being calculated for the code you can see here is that it's facing up, but its position is 0, 0, 0. So it's actually in the world at 0, 0, 0. And that's exactly where we've put our shadow plane as well at 0, 0, 0. So we've aligned these two things together. This plane is the one that you're actually raycasting to tap on to create the zombie, not that grid that's showing. So you can move that grid to align with the ground plane, or you can get rid of it altogether. It's not that important. It's the grid, I guess, is there for you to align it and get a sense of where the ground is. But when you're actually playing a game or doing an AR experience, you don't have that grid because you want to actually see the video feed of the real world. So the important point I'm making here, I guess, that I'm getting to, is that this ground plane here has to be in the same position as this plane that you want the shadows on. That's if you want your characters to appear as though they're walking on that plane with shadows that actually do attach to their feet positions. Otherwise, you might get shadows that come out halfway through your character if these two planes aren't in exactly the same place. All right, so now it's time to actually build it out and have a look at what we've got. So here's the game running on the Samsung. I'm going to line up where I want the ground to be before I start tracking, then press start tracking. Okay, so now we're tracking and you can see that the grid is staying pretty still. Tap on the screen, I should get a zombie. There's my zombie coming towards me, and I should be able to double tap and get it. Now, there's a few issues you can see here. Is that if you have too many bullets, they get stuck on the ground and each other. And every time I shoot a bullet, I'm also causing a zombie to spawn, which is not what we want. So we need to make a few adjustments. But you can see that I can move this around, and as long as those key locations stay within the camera, it will show the scene. If we just lost it there for a moment, now you can see that that's back again. And I'm going to have an absolute pile of zombies going on down there. But it's tracking quite nicely and moving like that. So let's just fix up those few little problems with the spawning, and then we'll try it out on my iPad. To fix the issues with the bullets getting stuck on the already dead zombies and on top of each other, and also the way that they're spawning a zombie when you actually create a bullet, I've just made two little changes. So in the chase code, I'm putting in this line here. So we're going to disable the collider on the zombie after it's been hit by the bullet to stop it actually being a physics object. So that will allow the bullet to pass through the zombie once it's dead. And then in the controller code, I've changed the double tap for the bullet to an actual two-finger touch. So a on began for a two-finger touch will instantiate our sphere / bullet, and the rest is all the same. So they're just the two lines of code that you need to change. Here we are on the iPad. So I swapped over the project to iOS mode and built it out to my iPad Pro, where I could actually capture the screen a lot easier than I could on my old Samsung. And you can see here I'm playing Shoot the Zombie on my dinner table. And it's working quite nicely. So it's picked up the key positions that it's getting from the video and using that to help align our game world. So you can actually move the iPad around, and as long as you stay focused on a very similar location, it will keep tracking the zombies. You'll see that my double touch isn't that great, and I'm actually spawning some zombies right back in the distance there. Of course, you could restrict that. Anyway, this is just a starting point for your own augmented reality application with Wikitude. So you can get the Wikitude plugin from the Wikitude website. The source code you'll be able to find on my website. And for anybody who's a Patreon subscriber for Holistic 3D will have free access to the whole project that you've seen in this video. So I hope you've learnt something and had some fun with this AR, and I look forward to seeing some great projects out there.